Thank you. Hello to everyone. I'm the grandpa of the conference. This morning we saw that OT and healthcare, or better, healthcare sector use OT technology, industrial IoT, and his main target is an important target for attacker groups. During my presentation, I will show you how to attack them. Okay? It's nice. In a live with the live demo, I have some virtual machines inside my PC, so we will try to attack, to exploit, to find some vulnerabilities and so on. Before to start, let me briefly introduce my experience. As Prejan said, I have more than 23 years of experience with the PLCs and SCADA, remote I/O, and so on. I work at 15 years in Schneider Electric. I know very well this kind of products, but not only. I'm a pen tester with a strong specialization in OT domain, and I'm the main developer. I'm the developer of SCADAsploit, the C2 that is targeting IT and OT domain with more than 100 of modules, auxiliary and exploitation modules targeting Siemens, Schneider, Rockwell, ABB, and other producer. And my current job, I'm the head of OT cybersecurity in an Italian company. I come from Italy. And I have also a private life. I have 4 children, and I'm very happy to be here because I'm alone. And it's a good opportunity for me to stay, to get a weekend absolutely alone. It's a fantastic dream. Okay, you can find some information. I have also a blog on omarmorando.com website, but this is not so important. So I have some questions. First question is why we talk about cybersecurity in OT domain. Because it's clear, industrial control system is a very target for APT group. Why? Because it's easier to attack an OT device. OT device means a PLC, means a strange device that works for 10, 20, 30, 40 years without any update, maybe. Okay, I worked in Schneider in Turin. Turin is northwest of Italy. And I left Schneider in 2005. During my work, I defined some architecture of the underground in Turin. Okay, that use a specific PLC called Modicon Quantum. This PLC is out of production since, I don't remember, 10 years maybe. But the underground, the metro, is still using this PLC. And you can Google Modicon Quantum vulnerabilities. You can find a long list of blogs that describe 12 vulnerabilities that can be exploited without any kind of difficulties, more or less any kind of difficulties. And this is the problem of OT device, of PLCs. The goal is economic or maybe also safety in certain cases. And the target, the OT, you can find OT in energy, water treatment, transportation, manufacturing sector, and in particular, critical infrastructure in energy. I don't want to bore you with Stuxnet. Stuxnet is not the only malware targeting OT, but I would like only to underline 2 important points related to Stuxnet. Stuxnet was the first malware targeting OT device. In the specific case, the target was Siemens PLC, S300 and 400, old PLCs that is running now also. But the important thing that I would like to underline are 2 topics. The first, Stuxnet was the first malware targeting OT devices, okay, targeting PLCs, and not standard computer in IT domain. The second important thing related to Stuxnet, it was the first malware, or better, was the first case that demonstrates that using a software we can damage something. We can have a physical impact, not a financial impact. In IT domain, I can steal data, I can grab account, a bank account, I can get money, but there is no physical consequence. It's depends on the situation, but generally speaking, there is no physical consequence. In OT domain and with Stuxnet, we know that it's possible to attack a PLC, changing the behavior of the plant and damage something. The safety problem is a very big impact. After Stuxnet, we have a long list of possible malware. One of them is Industroyer. Industroyer is a malware that is specific, developed to attack critical infrastructure. Why critical infrastructure? Because it uses, laser doesn't have acting on the monitor, it uses some specific protocol like EEC 5101, 104, OPC DA, and so on. Typical protocol, industrial protocol used in power generation plant, in power distribution plant. That means that this malware is able to target this specific domain. After the first version, we have Industroyer V2. V2 is the reloaded version. In April 2022, was discovered a new version, a steroid version of Industroyer that is able, with more efficient capability, to find, to identify the right target, the right protocol, and to, in fact, distribute the malware over the network with a very impressive impact. After Industroyer, I would like to underline another malware, that is Triton. What is Triton? So, in a plant, in an industrial plant, you have the emergency button, the red button. When something is wrong in the plant and you are in a safety situation, in critical safety situation, you can push the red button and the plant is stopped. Or better, it's not stopped. It depends on the configuration of the what is called safety instrumentation system. The plant is put in a safety situation. That means close the valve, I don't know, decrease the temperature, it depends, okay? And there is a very big producer of this kind of device that is Triconex. Triconex is a worldwide company that produces safety information instrumentation, instrumented system that is I can say, the bigger producer of SIS system. Triton is a malware that is able to target this device, intelligent device. That means that when you are in trouble, when you are in a critical situation in your plant, you push the red button and the situation grows in terms of critical impact. That means no safety situation can be protected pushing the red button, because this kind of malware is targeting in order to block the red button, block the right behavior defined by some engineers, and you can have catastrophic consequence for the people, for situation, for the infrastructure. Okay, so what is inside a PLC? What is inside an ICS system, an industrial control system? Starting from the bottom to up, we have the sensors and actuators. Sensors is a sound device that translates a physical value to a digital number. Temperature, pressure, speed, it depends. Actuators do exactly the opposite. Transform a digital value to a physical action. Motors, pump, valves, and so on. Then we have, growing up at level 1, this is a Purdue model that describes the 5 levels of the ICS plant. At level 1, we have the PLC. PLC is a programmable logic controller, is a sort of computer that gets the information coming from the sensor, elaborate the program inside, and then actuate the actuators. Then we have HMI. HMI means human-machine interface. Level 2 is a display, embedded computer, or PC with a specific software that show all the information to the operator. Alarm, event, or get command coming from the operator. A set point, or a start command, stop command, and so on. And then we have a SCADA system. SCADA system on level 3 is a supervisory control and data acquisition. Means it's a software that runs inside the PC, Windows PC in most of the case, then collect all information coming from different PLCs using specific industrial control protocols. Industrial protocols means Modbus, TCP, Profinet, DeviceNet, OPC, UA, CAN Open, or DeviceNet, and other specific protocols. Consider that in industrial control system, we have more than 150 proprietary protocols that are specific for industrial control system. It depends on the vendor, are produced by the vendors, are defined by the vendors. We have some standard protocol like Profinet, Modbus, and other protocols, but some protocols are defined by a specific vendor for their equipment. Okay, but what's inside the PLC? Because if you consider PLC, maybe something strange, is something I can say that is not so, that can be scary, okay? It's a sort of the dark side of the force inside the PLC. It's something strange because I don't know what is. It's a PC, it's a computer PC. What is running inside? Which kind of operating system is running inside the PLC? Running inside the PLC is embedded Linux, more or less. Inside the PLC, you can find, in most of the case, a Linux operating system, like, I don't know, Allen Bradley, Microware, OS 9 is Linux-based. B&R, a strong company, WixWorks. Rockwell ControlLogix, WixWorks. Schneider Electric, in some PLCs use UnitOS. UnitOS is a Linux-based PLC. Or in another, Schneider Modicon Quantum, Metropolitan in Turin, WixWorks. Siemens use a custom version of Linux, it's called Adonis OS, but it's a Linux embedded system. Or in certain cases, Windows RT or Vago is another producer, use a Linux real-time. That means that you consider a PLC exactly as a PC, with an embedded system, without keyboard, without HDMI port, without mouse, in certain cases with some USB port, with some memories, with real-time extension. This is a very big difference. That means that this Linux embedded system is a very limited version in order to have the best performance possible in terms of real time. Consider a cycle, execution cycle of the program inside PLC can take more or less 10 milliseconds, 20 milliseconds, in most of the case, I don't know, 80 milliseconds, but no more. And every loop is executed every, I don't know, 10 milliseconds for 30 years, okay? So if you take a small PLC from Siemens, S7 1200, and open it, you inside will find an ARM Cortex R4. What is a Cortex M4 is a typical low price microcontroller specific for real-time application, but it is a standard component that is used, for example, in embedded application like automotive. Some ECU that control the vehicle use R4, or imagine processing, mass storage, HDD, or industrial microcontrollers. And this version of controllers, R4, has a high-performance solution for real-time application, real-time reaction, but is absolutely a standard controller. It means that you can use the same hardware attack, the same approach of a standard IoT device or embedded device. For example, as I said, Adonis, a real-time operating system, Linux-based from Siemens. Inside you have the kernel is divided in two sections. The first is the library operating system services, and on the other side, we have all the services related to the automation. But if consider this PLC as an embedded system with Linux embedded, you can find also some web server. Today, in most of the case, all the PLCs has inside a web server running Apache in order to provide a very comfortable user interface using a browser. You can put in the browser the IP address of the PLC. If you don't know the address of PLC, you can open shodan.io and you can search for Schneider, TSX, Siemens, S7, or you can use Chances. IO is the same. You can find a long list of direct IP exposed on the internet. You can connect or you can browse the PLC and you can find a user interface, a very basic user interface provided directly from the PLC. But you can also use a standard tools like DIRB, DIRBuster, GoBuster, Nikto, or other tools, or Barb Suite to evaluate the website. Please do that. It's very funny, okay? Or there are some other problem typical for computer, that some vulnerabilities like sandbox. Consider inside the PLC, in this case Adonis, all the application run inside a sandbox to protect and prevent, I don't know, to protect memory, file system, and so on. But there is some vulnerabilities that are typical of a computer, and one of them is the sandbox escape, and that allow you to take the control of the operating system starting from the connection, passing through the protocol, communication protocol. So why we talk about C2? The first point is why we talk about adversary simulation. In OT domain, you can find a long list, not so long, but okay, some tools that can be useful to identify vulnerabilities. Tenable OT, this is the Nessus version for OT domain. You can find Clarity, you can find Nozomi Guardian, you can find the RadiFlow, Armies, that are typical tools that scan the network, grab the information from the PLC, and tell you, okay, this version of the firmware of the PLC is vulnerable to this, is potential vulnerable to this kind of CV and so on. But this is not a real scenario. I mean, how can I'm not sure if I can exploit this kind of vulnerability. I'm not sure that this tool is able to identify possible kill chain or path attack in a real case. So adversary simulation is something that can help you to identify the right capability and the right exposure of your system. The attack surface that can be more and more bigger respect of the scanning, basic scanning can do using this tool. So adversary simulation in OT, why adversary simulation in OT? Can help you to identify weaknesses, unnoticed or traditional, that cannot be identified using traditional tools, as I said before. Or you can have the benefit of realistic threat scenario, passing through the web server of the PLC, passing through the protocol, passing through, I don't know, it's depends on the scenario. Response evaluation. Another important point is the SOC assessment. Is your SOC able to identify an attack coming from OT that is going up to IT, or from IT that is going down to OT? It's depend of the rules, it's depend of the playbook, it's depend of the capability of the instrument, of the settings of the instrument, of the IDS or IPS. Or better, risk mitigation and compliance assurance. Why compliance assurance? Because there are new important regulations that are coming in order to not only the NIS2, of course, but also other specific standards that are related to ICS and OT domain. So how SC2 works, I think that you are very comfortable with this kind of slide, but only to put some important point. We have a team server, we have a server that is running our C2 core, waiting for a victim to be connected. We have at least one or more than one commander, remote commander, that can be remote, of course, or in the same machine, it depends. And then we have the potential victim. The potential victim that are affected by an agent, a dropper, a beacon, a badger. It depends of the C2. Some C2 call beacon, Cobalt Strike call beacon, Brute Rattle call badger. It depends. That means an agent, a malware, a backdoor, a rat, that is connected to the team server in order to receive command from the team server and from the commander. And in this case, we can use different kind of protocol, HTTP, HTTP, HTTPS. You can use DOH, DNS over HTTPS. We can use external C2 like a Slack, Driver, or Teams, or Discord. And then using different protocol, we can pivoting, we can do a lateral movement using SMB, for example, and grabbing and cover all the network and discover all the network and pass the command also to the other victim 3/4 depend of architecture. This is more or less a typical architecture of a C2, of a command and control. Nothing new. Why a C2 in OT? Because considering the Purdue model that I showed before, level 0, the process, sensor actuator, level 1, our PLC, level 2, the supervisor HMI and SCADA, we have a level 3, that means production, plant, and so on. Then we don't have DMZ, because it's not so common DMZ in industrial control system. And then we have the level 4 and 5, that is a corporate network. The problem is that an attacker have a very huge attack surface in a OT plant, because it can use, for example, supply chain attack, grabbing credential for a supplier. If you buy, I don't know, consider Ferrero that produce Nutella, maybe you know, or Barilla that produce pasta, okay? They have a long lane to produce the pasta. That means that is some machinery that produce, I don't know, change the mix of the different components, cook the pasta, and then put the pasta in a bag. And there is a machine that is a packaging machine that put the pasta inside a bag. The producer of this machine, of the packaging machine, is, I don't know, is not Barilla, is a OEM, is a producer specialized in packaging machine. That can be a small producer, is not Barilla, is a small producer. And this producer usually provide a remote assistance for their client, their customers. That can be in Italy, that can be in US, that can be, I don't know, in Bulgaria. So they provide remote assistance. How this service remote connection is protected by the small producer? They use TeamViewer, AnyDesk, remote connection. How they protect their credential? Because if I grab the credential, I can enter not in the machinery, I enter in the lane of Barilla. And if there is no segmentation, network segmentation from OT and IT, I can go up looking for the server of Barilla, I can encrypt, steal data, and so on. So remote connection is a very big program in OT domain. Another big problem is infected laptop. I'm a Barilla guy. I'm the maintainer of the Barilla BI. I'm the programmer of the PLC. I use my PC for change the configuration parameters inside the OT plant. But I use my PC also for email, web server, web surfing, searching, and so on. It's absolutely common. The same PC, same laptop is used in both the domain. It's very difficult to find a customer that use separated PC or a virtual machine inside. What's virtual machine? For OT guys, it's something strange. So they use the same PC in IT, then put the problem is, in certain cases, this PC required a specific configuration. That means that EDR is not so easy to put inside. Or better, some malware that are not targeting IT domain are not identified by the EDR because it is out of scope. But if you put this PC with this OT malware in the OT plant, you can transport and put the malware inside this protocol. Another common use is the infected USB. USB in OT domain is something absolutely standard because they need a manual in PDF format, they need to share schema, they need to share program, and so on. So infected malware, infected USB is absolutely common. Then in secure remote support, coming from IT and going down without segmentation, it could be possible going down to the OT domain. So that's the reason why I started to use to develop 2 years ago SCADAsploit, strange name. We know Metasploit. Metasploit has more than 6,000 modules, auxiliary, exploitation, and commands modules. The problem is it has also more than 70 modules for SCADA. The problem is that these modules are not targeting European market, are not targeting a real situation. You can find 2-3 modules for Schneider, for Modbus. You can find 2-3 modules for Siemens, and then some strange devices that are not used in Europe and in the main OT market. That's the reason why I decided to develop something that is absolutely targeting OT domain with a long list of modules, but also able to be used in IT domain. That's the reason why I implemented EDR revision, anti-malware, scan interface, even tracing for window bypass, anti-sandboxing or anti-debugging, process injection using indirect syscall, NT-API, and so on, multiple pivoting techniques using SMB, TCP, or RPC, different kind of beacon, staged and stageless beacon is depend of the architecture, or expandable using payload with a BOF. BOF is beacon object files introduced by CobbleStrike. Is a C code compiled but not linked. Very small code is an object file, is a standard format that you could put inside the agent that is running inside the victim, and you can, with a very small file, you can increase the list of the possible command that can be executed on the victim. Or another interesting thing is that the server can be run inside an ARM computer. That means a Raspberry, very small Raspberry. That means that you can put a Raspberry inside a network as a stealth installation, like Mr. Robot in TV, that uses a Raspberry Pi put inside a connection with a modem 4G or 5G, depending. You have a web server, absolutely, a team server, absolutely accessible from remote. So interesting, but the scope, the goal of my presentation is not to promote SCADAsploit. The scope is to underline the importance of ICS cybersecurity, OT cybersecurity. To install a beacon, an agent inside, you need a dropper. What is a dropper? A dropper is something that puts your malware inside the victim. And there are different kinds of dropper that you can use. A file-based dropper, something that is a tool, programs or tool, document-based dropper, PDF or XLL, for example, USB-based dropper, in case of infected USB, or web script dropper like JS or VB or other file. PDF in OT is more than the 65% of the file, or better, more than the 65% of the PDF are used to compromise an OT device. Okay. Then we have Office, Doc, PPT, Excel, it's depends. But it's easy to understand that if you run an Excel, you have the banner, this file contains a macro, do you want to do, but you can bypass this kind of process using, for example, XLL format that doesn't require this, absolutely recognized as a good file from Microsoft, and you can open an XLL, that means an Excel file, but is a DLL inside that can contain some part of malware. This is a basic approach. For example, this is a real case applied during some adversary simulation in Italy, and we use a phishing server, a spear phishing, with an XLL inside, bypassing the mark of the web protection. Open the XLL, and you have opening the XLL by Excel. The XLL is was signed as a standard, as a recognized file. XLL was open, and then we have the dropper that can bypass the EDR protection, and then using external C2 we can connect with the remote commander. This is a standard approach, as you know. This is not absolutely new, but is exactly the same path attack or kill chain that you can use in IT can be used in OT domain, because in OT domain you have computer with a SCADA system, you have engineering station for programming the PLC, that is a window computer, you have window embedded system for HMI, so more or less it's the same with a low level of protection, because ADR is not so common used in OT domain. Antivirus is not so used in OT domain. Demo. But before the big disclaimer. The big disclaimer: activities to be performed in a test environment, laboratory, during plant shutdown for maintenance. That means, please don't do an adversary simulation during the production plant of Barilla. Okay, to test if it's possible to attack the PLC. Is possible. Okay, the answer is yes. If you can reach a PLC, you can create a denial of service in 10 seconds. Don't do that. Okay. But okay, it's important. We know that it's important to underline that all these phases must be performed in a lab to simulate the plant, or during maintenance according with the customer. Okay. Oh, in my PC I have this configuration. I have a team server, I have a remote commander, all in the same machine, of course, and I have 3 virtual machines, one with Windows 11, not 10, with Defender and another ADR. Okay? And then I have 2 virtual machines that simulate, one simulate a PLC and the other one simulate an HMI product. Okay. Okay, I run the team server. Boom. And then I run the remote commander. Remote commander is something like that. I don't know if you are familiar with command and control. In this case, the team server is developed using Go and Python, and the remote commander is developed in C++ using Qt library. It's multi-platform. We have a listener. What is a listener? It's a service that waiting from a victim connection in order to send and receive command to the victim. I prepared 3 listener, one that is based on HTTP, the other one that use HTTPS, this port, and an SMB for pivoting, but we don't have time for pivoting, but okay. Believe me, we have it. Then inside this remote commander, we have other tabs, but it's not so important. So for one important thing related to a command and control is what is called a malleable C2. Malleable C2 means a command and control that is able to adapt their behavior, its behavior, depending on the architecture. That means, in this case, we need to create dynamically an agent that use one of these protocol and that use different techniques to bypass the ADR depending on the system, of course. We can, we have also the network map here. We have the team server. Okay, badger list. We want to create a beacon. I go very quickly. We have a long list of possible parameters. If you don't need what they mean, we have a LERP here. But in this case, I don't want to bore you. We can create different kind of payload, as we saw during my during the presentation before me from Black Cat. We can create a Windows exe file, executable file. We can create a Windows DLL. It's dependent. Or we can create a service executable. We create a shell code using this protocol, some different techniques to bypass, to obfuscation, to cover the communication from the agent and the team server in order to prevent firewall protection, to prevent IDS and IPS protection, to prevent alerting the SOC analyst, for example. And we can use different techniques. I chose directly waiting for single object exe. We can add some technique slips like jump RAX register. We can want to bypass AMSI, and then we can encrypt. I will change my encryption algorithm for the next version based on your presentation. Thank you so much. Basically, at the moment, I have AES algorithms that are targeting different approach. For example, AES encrypted Q user APC, or in this case, I will use direct syscall execution, and then I flag indirect syscall. Choosing this possible combination of the agent, I push the generate button, and dynamically I compile my malware, because it's based in C language and assembly language, generate some tricks, then encrypt the payload, and finally we have a binary. It takes a while. Yeah, we have the binary. I put the binary here. and I call it do nothing. I think it's a good name. Okay, so now I have here my Windows machine. I need to put the malware inside my Windows machine. Of course, the pre-exploitation, that means what it means. I need a dropper. I need, I don't know, a document, a PDF, and I don't know what you want to put inside this machine. For the demo, I don't have the opportunity to show how to drop my malware, my agent inside, because it takes a long time. But in this case, it's very simple. I use AppDog. Do you know AppDog? Yeah. AppDog here. I have the Defender that is running. I put here. I have do nothing. Okay, thank you. Okay, first alert. Mark of the web. Mark of the web means you are downloading an executable file from internet. No good, no good. But in this case, okay, please. Keep my file. Are you sure? Yes, keep my file. Sure. Yes, keep my file. Okay. No analysis from ADR. No alerting from ADR. Okay? Good. Run it. I run the process. I run the process and boom. Yeah, we have it. Okay? This is the first line is our victim machine that is connected to the team server using the malware or the agent that we have generated right now. If I go on the network map, I have my server and I have my victim. Okay? What I can do? A long list of possible commands. The first is interact with beacon. Okay, who am I? Now I'm sending the command to the agent and I grab some information coming from the system. Or I can do dir and I have the list of the file here, this list. Or screenshot, very basic. Okay, download, screenshot, this is my screenshot, for example. Or better, shell calc. I send a command and calc is compared. Yeah, good. It's funny. But this is a standard command and control. You can do the same using Cobalt Strike, using Brute Throttle, using Sliver, it's not so interesting from my point of view. No, it's interesting, but okay. We can do better. What we can do? For example, OT, all the modules, all the commands that I implemented inside SCADAsploit start with OT underline. OT netmap. What is OT netmap? It's a command that in trying to discover all the possible interface inside the computer. And we find another common interface that is here that use port 502. Port 502 is used for Modbus TCP protocol. Oh, good. So we have first information related to our infrastructure. Why? Because we are here. We have the first connection to the IT level, and then we have the second connection, second network interface to the OT level. Good, funny. What you can do? Modbus, OT, Modbus scan is a module that start scanning the OT device using the Modbus protocol. I can enter the list of IP addresses, /24, a range of addresses, or a single IP address. In this case, we use this range because I know it takes time, so instead of do /24, I know that my virtual machine has one of the, or better, two of these addresses. Enter. It takes a while. Yeah, we have it. We discover two devices. The first is the vendor is Schneider Electric. The device is a PLC. The model name is Modicom M580. The CPU module is this one. The network modules is the same because the CPU has inside two network connection embedded. We have the version of the firmware 3.10. We have the name of the project, the revision, the version of the project. We find a lot of things and the MAC address. Then we discover another device is an HMI, human machine interface by Schneider, that is called XBT GT43, this version and this MAC address. Interesting. Are important information that we got from the PLC. For example, firmware version. I can Google Modicom M580 version 3.10. I suggest also 3.20 because I worked on these vulnerabilities. They declared to fix this vulnerability with the 3.2, but it's not covered. Okay. Oops. No, it's not true. You can use also using the 3.2 version. It's the same 3.20. And you can find some vulnerabilities that can be addressed with this kind of version of the PLC. We have some information related to the project revision. If I'm an insider, as we saw this morning, maybe I don't know, I was an employee inside Barilla. I was the programmer of a PLC of Barilla. And before to leave Barilla, I copied all the project file inside my computer. If I identified the same version after 3 years, it means that I know what is inside the PLC because it is exactly the same version that I have. That means they can analyze the software, I can analyze the different steps of the software, and I can use this project to attack Barilla, for example. Or we identify which kind of tools was used to program this PLC, version V14.1 of Unity Pro software. Other possible vulnerabilities. But what is funny is that here now I have two PLC, one PLC and one HMI. This is a specific function of SCADAsploit. I mean, if you use Cobalt Strike, you cannot see these devices, for example, because are not computer, are not Windows-based. In this case, we can do that. What we can do, next step, we try to attack the PLC using, this is the simulator of the PLC. We can, for example, attack using or exploiting a vulnerability that is called 2018-7055. I know it. I have another module that is called Modicom 7855. This vulnerability is called set breakpoint vulnerability. I mean, when you program a PLC, you consider a PLC as a PC. It means that if you are familiar with the development tool, you have inside your Visual Studio Code a debugger. You can put a breakpoint to stop the execution of your code, and then step by step analyze the data, changing the data, and so on. You can do the same with a PLC. You can do the same using Unity Pro for Schneider or TIA Portal from Siemens. But there is a vulnerability inside this PLC. If you put the breakpoint address to 00, you stop completely the PLC. It stops completely. The CPU is stop, Ethernet communication is in stop. We can try to do that. And the address is this one. Sorry, there is a mistake here. Okay, try to do that. Pum. Yeah. Okay, this is a simulator, but I exploited this vulnerability. I set the set breakpoint with the breakpoint memory address to 00, and the CPU is completely in stop. I have a physical PLC at my home. If you search on YouTube, you will find the same exploitation with the physical PLC. Okay, believe me, this is of course, is a simulator, but the behavior is exactly the same. So, okay, so it means that I'm not only able to identify vulnerabilities, but I can also test if this vulnerability can be exploited in a specific case. Okay, I think this is quite funny, not for the customer, but or for the potential victim. But if you are engaged by a company to do a red team or adversary simulation in OT passing through IT, I think is very, very funny. So, okay, two last slides. Make it safe. What we can do, what we have to do to protect our OT system. The first measures are organizational measures. That means security assessment, evaluate your network, evaluate the risk. So it means perform a risk assessment or business impact analysis related to OT for Barilla or for steel production. Awareness. This is absolutely very important to training people in order to be aware of the risk of the OT devices. Protect the supply chain. Protect the remote connection from the supplier, and policies and procedure. Technically speaking, asset inventory, asset discovery. I give you an example. In Italy, we have an important car producer. We have more than one. But one is very known internationally, very high level of vehicle, okay, red. I don't know who is. And we perform an asset discovery. We talk with the customer before to do that, and they said, okay, we have more or less 500 PLCs in our plant. Good, 500. Okay, we will take 3 days for asset inventory and so on. We do the asset discovery, and we found 960 IoT devices, exactly the double, okay, more or less. Because, why? Because PLCs are 500, okay, but then you have digital balance with the IoT device, you have microscope instrumentation connected to internet, you have, I don't know, other tools that are, industrial IoT, that is exactly the same of a PLC, that use industrial protocol, that use embedded system, and can be exploited by someone else, okay? Network segmentation is absolutely important to protect and to subdivide the network in different levels using OT firewall, OT IDS, OT IPS, able to perform and to do the deep packet inspection of industrial protocol, endpoint protection, secure PLC programming, patching where is possible, and secure remote access. So takeaways. Awareness of OT, cybersecurity, and risk. This was my goal of my presentation today. The importance of validate the safety posture, but really not running and Tenable OT or Nessus says you are okay, go without any kind of problem. Knowledge of a very effective tool of Red Team, but is not the only one. You can develop your buff, you can develop your tool, is not so important. What is important is to focus your tool and your approach to the OT target using the OT techniques. Don't believe anything and anyone, even me. And take care of your cybersecurity OT system, because if you don't do that, someone else will. But maybe will be APT, probably. Okay, so if you want to buy a SCADAsploit Lego version, no, it's a ChatGPT production. It doesn't exist. Okay, thank you so much.